Chapter 6, Sample Problem Number 4. A block is moving to the right across a rough table at a constant speed of 2 meters per second. The tables and blocks are identical in the two cases. In case A, the block is pushed with a stick, and in case B, the block is pulled with a string. The angle that the applied force makes with the horizontal is the same in both cases. Will the magnitude of the force on the block by the stick in case A be greater than, or less than, or equal to the tension on the block by the string in case B? This is actually similar to one of the ones earlier in the problem in the sample set. It's almost the same question. So we can just quickly, let's do some assignments. Let's call this our blue guy, and we'll call this guy our purple guy. And so we'll want to do our free body diagrams. So here we have the weight pulling down, and the normal pushing up, and a frictional force resisting. How do we know a frictional force? Because it is a rough table. And then we'll have the downward sloping force, which I'm going to skip a little bit and jump right to the idea that the stick both pushes it to the right, and call it FPX, and also pushes it down, and call that FPY. And in a very similar fashion over here, we'll have a weight, which will be the same. This FG and this FG, being the same symbol, should be the same value, and they're the same because the blocks are identical, meaning that they have the same mass and therefore the same weight. There's going to be a normal force, and you might be tempted to think, well, then that has to be identical as well, but that isn't necessarily true, because the normal force is not intrinsic to the block. It's an interaction between the block and something else, and so we have to worry about how that works out. So right now I'll leave it as is, and likewise there'll be a frictional force, and we don't know if the frictional force will be the same, so I'll call that FFB. And then we have the tension, and once again I'm going to take this tension force and I'm going to say, well, it acts in two different directions. It pulls to the right, but also pulls upward. And then we're going to lastly loop in on the fact that they moved at a constant speed, which means that the accelerations are 0. And that's the vector sense of the acceleration, meaning in all the different directions. So our basic way here is to say that this minus this minus this, which is our net force vertically, FNA minus FG minus FPY, has to equal the mass times the acceleration, which is 0. And this have to add to 0. So we'll have FPX minus FFA is going to be 0. And analogously over here, we'll have FT or FNB minus FG plus FTY, because this one is pointing upward, the same as Fn, so they come with the same sign. And those will have to equal the mass times the acceleration, which is 0. And likewise, this plus this in a vector sense, meaning if this is positive, then FFB has to be treated as negative, and that's 0 as well. Why is that helpful? Well, if we take this first line, we can solve this over and say that FNA is FG plus FPY, so that it is greater than FG. Whereas if we take this line, we see that FNB is FG minus FTY, and that means that FNA is bigger than FNB, since A is the weight plus something and B is the weight minus something, so A must be bigger than B. But the frictional force, remember, is mu, in this case kinetic because it's moving, times Fn. And so we sort of have a chain of events that are coming out where we can say that Fna is greater than Fnb, and that implies that FFA is greater than FFB. But notice that in both cases, the horizontal part is equal to the frictional force because there's no other forces and they have to add 0. And so that tells us that FPX is greater than FTX. Just want to fix that. Why is that useful? Because since they have the same angle, the x component is just proportional to the total thing, and so we are left with that FP has to be greater than FT. And then sort of at long last, maybe I should use their symbols, so F is greater than T. So we find that the actual answer here is the force in case A is greater than the force in case B.